Okay, so when you have radicals, what do you think a common technique is? Square both sides. And the unfortunate thing about radicals with these, when you square both sides, you might introduce extra answers. Remember when we had to do the checking thing with those absolute value equations? Does that ring a bell? Where we had like absolute value of something equals an x on one side. And so in this case, you're going to have to also check.
Yeah,
so
you have to check one side.
You've actually got to check your answers. And it is the case that they could both work, one could work, or none could work, and you'd have no solution. So, but the basic idea that, okay, yeah, you square both sides is the good place to start. So when you square both sides, you get x squared equals what? X plus 2. And so probably going to solve by factoring, right? So move the x and the 2 on the left. You get x squared minus x minus 2 equals 0. And then that factors pretty easily, doesn't it?
Yep.
Yeah, into x.
Minus 2.
Yep.
X plus 1.
Yep. And so one answer is 2, or one potential answer is 2, and one other potential answer is negative 1. Okay, so when we check them, check please, does 2 equal root 2 plus 2?
Yes.
Yes, so that one works. Does negative 1 equal root negative 1 plus 2?
No.
No. Negative 1 equals root 1, and root 1 is defined to be just 1, so no. And the reason this happens is when you square, you kind of lose some information about the negatives. So when you see a root thing, you're probably going to always have to check. And there isn't a hard, fast rule. Like, it is completely possible that one answer works, both could work, or none could work. And if none work, then it's none of your two answers work. Two things happened. You did it wrong, or it is no solution.
Well, if you have the side that's not the square root, if that side's negative, then you know it's not going to work.
Yeah, but there are other situations in which it wouldn't work as well. Okay, so how about, so same idea, square both sides. I'm going to make a mistake on purpose. What did I do wrong?
You missed the middle term.
I missed the middle term, right? So everybody knows, so you guys should all know x minus 5 squared isn't x squared plus 25, right? So the part that's wrong was this part. What should it have been instead?
X squared minus 10 plus 20, well, minus 10x plus 25.
X squared minus 10x plus 25, very good, yep. So x squared minus 10x plus 25. If you make a mistake, that's one thing it's going to be. So if you all know how to, I mean, it's common that when you know how to square, but then having to square middle of the problem's a little bit tricky sometimes. Okay, now how about you move the x over to the left and move the negative 3 over to the left. What do you get? Uh-huh. Great. X squared minus 11x plus 28. And hopefully that factors.
It does.
Yay! 7 and 4?
Yep.
So that factors into x minus 7 times x minus 4. And one potential answer is 7, and one potential answer is 4. When checking, plug into original. Does that make sense as well? Okay, always the original, because the place where you introduced extra answers like happened somewhere in one of the first steps. So let's try 7. So does 7 minus 5 equal square root of 7 minus 3? Does that work? It appears to, right? 7 minus 5 is 2, right? 7 minus 3 is 4, then your root, you get 2. So I just care that you, like, show me you've checked somehow, right? How about 4? Does 4 minus 5 equal square root of 4 minus 3? No. So what you could do, you could do two things. You could just only circle the one that actually is the solution, or like just totally cross out the one that actually isn't. So it's totally obvious you don't know, you think that that's not a solution.
Well, is negative 1 not the square root of 1?
It's not, yeah. So that is a technical thing. But when I give you square root of a number, it always means the positive one. And it's because the square root is a function, so one input goes to one output. So for it to give you the negative, it has to be negative square root of 1. Does that make sense? That's a technicality. Okay. Sometimes you have to square twice. And it's a bit tricky. So you're like, So if you looked at this, what would be your first instinct as to what you should do?
Square.
Now, is it legit to do like this? No, that's not okay. That's the same thing as saying a squared distributes. So that's out. I think it would probably be easiest. So do you really want to do like this whole big thing multiplied by itself? No. So what I would think is the best thing that I can do is get one square root by itself. Does that make sense? So like write it as root 2x plus 5 equals 5 minus square root x plus 2. And then at least when I square the piece on the right side, at least I'm not squaring a root plus a root, right? It seems like I might be able, and one root's gonna go away, right? So take this expression, and we're gonna square this, and we're gonna square that. So that gives 2x plus 5. I'm actually gonna write this one down, like a lot of the steps. 5 minus root x plus 2 times 5 minus root x plus 2. Is everyone okay with what I'm doing? You can cry because it takes half a page paper, okay? Like you're allowed to do that, but. Okay, so that's 2x plus 5. Now, what do you get when you're distributing on the right side? First, we'll have 25 minus how many square roots of x plus 2? 10. And then the one tricky thing, that comes from multiplying root x plus 2 times root x plus 2, right? What did I forget? Yeah, this needs to be in parentheses. Does that make sense?
What is a negative and a negative?
Yeah.
And it should be positive. I forgot two things. Sorry. Okay. All right, well, that's at least, it's at least 2x plus 5 equals, let's see, what is it? X plus 27 minus 10 root x plus 2, right? Does that make sense? And you're thinking, well, at least I can get the x's and the constants together, right? So take away x, and you get x on this side. Take away 27, and you get
Minus 22.
minus 22. And at least at this point in time, you have successfully killed off one of the square roots, right? So now what could you do?
Divide by -7.
I would avoid fractions if at all possible. I would square everything. Does that make sense? So square this. Feel free to use a calculator for humongous numbers if this happens, okay? That becomes x squared minus 44x. I don't have 22 squared memorized, but my notes say it's 484. Equals 100 times the quantity x plus 2. Okay, so that's x squared minus 44x plus 484 equals 100x plus 200, right? Man, so x squared minus 144x plus 284, right? Okay. I know it's painful. And you're hoping like, oh my gosh, please factor, please factor. And please factor and be an easy factor, right? I don't know the factors of 284, but what is 284 divided by 2? Yeah, 284 divided by 2 is 142. Why is that helpful? Yeah, so 142 and 2 makes 144, right? So this factors into x minus 2, x minus 142. Somebody tried real hard to make this problem work out and have pretty answers. And so you get x equals 2 and x equals 142. Now that stage, you're so done, you don't want to even check your answers, do you? No, but checking isn't very hard, is it? So we'll check 2 first. Okay, so you plug in 2, you get root 4 plus 5 plus root 2 plus 2 equals 5. Does that check out or not? Yes, it does. Okay, great. When you check 142, holy moly, okay, so 2 times 142 is 284 plus root 142 plus 2, does that equal 5? It doesn't take a calculator to tell you that that's not going to work, right? You're going to have like humongous numbers equaling 5. No way. So that's not an answer. And I realize that every example that I've done has had exactly one of the answers work out. It is not always like that, so don't be fooled. Sometimes both answers will work and sometimes none will work. When we talk about graphing functions, I can explain another way to understand why. Okay, so absolute value equations. So you had something like this on your quiz, I think. I wrote the quiz a long time ago, so I kind of forgot. But the way that we solved stuff like this was by making 2 equations. Does that ring a bell? Mm-hmm. So the first equation that you solved was the obvious one. It was that, well, 3x minus 4 equals x plus 4. What was the other equation that you solved?
3x minus 4 equals minus x minus 4.
Equals negative x plus 4, which Daniel went ahead and already distributed as 3x minus 4 equals minus x minus 4. So for the first one, we get 2x equals 8. Does that make sense? Was that too fast?
No.
And then x equals 4. The second one we get 4x equals 0, so x is equal to 0. Do they both work? So when you plug in 4, you get the absolute value of 12 minus 4 equals 4 plus 4. Does that check out? Yes, so 4 is a legit answer. When you plug in 0, you get the absolute value of 0 minus 4 equals 0 plus 4. Does that one work? Mm-hmm. Yes, okay, great. So both answers worked. Sometimes one will work, sometimes none will work, but in that case both of them did. So that's still a legitimate way to solve these equations. There is another way. The other way you can solve this is by squaring both sides. Because, if you have a negative, squaring both sides will sort of get rid of the whole plus minus thing, right? So if you square both sides, you can kind of say, oh, the absolute value, then that squared is going to be the same thing, because if it's a positive or negative number, they'll square to the same thing. So you can square this side and square that side. We're going to get the same answers. So on the left, you're going to have 3x minus 4 equals, what is x plus 4 squared? So we're doing this the second way is to take this expression and square both sides.
So if it's in an absolute value.
If it's in an absolute value, the whole thing that's funky with absolute values is they equal two different things. They equal positive the number or negative the number, right? And one way to deal with that and sort of make the negative go away is to square both sides.
Because isn't a absolute value kind of like radical?
Yeah, and that's also a thing. Remember how we also said the absolute value is kind of like a square root of something squared, right? What was the order specifically that did matter? It was the...
So just like any time, just treat it like a radical.
Yeah, you can treat it like a radical. And the other method is still legitimate and fine. Like, it still works. It's not wrong. It's just that another way to do it is to square both sides. And it will also work. And I just want to show you that it actually happens. So 3x minus 4 will equal, what does x plus 4 squared become?
X squared plus 8x plus 16.
And holy moly, I'm an idiot. If I have 3x minus 4 squared, I have to do 3x minus 4 multiplied by 3x minus 4, don't I? No wonder you were confused, because I was being stupid. I'm so sorry. So this should be 3x minus 4 squared equals x plus 4 squared. I'm so sorry. Math at 8 a.m. Okay, so that's 3x minus 4 times 3x minus 4. And Natalie, you said what the other side was. Could you tell me again?
X squared plus 8x plus 16.
Mm-hmm. I only wrote the stuff out on the left to show you that pattern there, just because it's a little bit more tricky. That's 9x squared. And then does it make sense you're going to get minus 12x and minus 12x again? So minus 24x plus 16 will equal x squared plus 8x plus 16. And you think, oh man, I have x squared, it's multiple things. Do you want to put all the stuff on the left or all the stuff on the right? Left. So 9x squared minus x squared will make?
8x squared.
Uh-huh. Will you take away 8x or add 8x?
Take away.
So 24 minus 8, if it's 24 degrees below 0 and goes down 8 more, we're crying, it's minus 32. And what happens if you take away the 16s? 0. Okay, so equals 0. And then there probably is a greatest common factor, right? 8. Mm-hmm. And one thing is 8x equals 0, so x is 0 is an answer, and x equals 4. You would need to check, but why don't we have to? Yeah, we already have, right? We checked them for the last one. It's like if you were doing this problem on its own and you hadn't already checked because you did it 2 ways, you would have to check them. So I don't really prefer, I kind of prefer the first method because it's the way that I learned first, but this also works. If you want to do it this way, you totally can. All right. Now the next thing is legitimately, I think, a little bit hard, but the idea of what happens here does come up in calculus. So one idea that comes up in calculus towards the end of the class is you take these things and you try to make them look simpler so that you can actually use techniques you know to solve them. And we're going to apply a similar idea to factoring. So how is this factoring problem different than the previous ones we've seen? X is raised to the 4th. Does that make sense? That's a little bit weird. We've only had x squared, right? Yeah, so one thing that you can do is you make a substitution and you say, well, I'm going to let something, and the letter usually is u equals x squared. And if u is x squared, does it make sense that u squared is x squared squared or x to the fourth? Does that idea make sense? So what you can do is, if u squared is x to the fourth, you can replace the x to the fourth by u squared. That becomes 13u plus 36. And then develop temporary amnesia and forget the original problem existed and just solve the second one. So can you factor u squared minus 13u plus 36 equals 0? Yes, Willow?
Couldn't you still factor the top one, just by keeping track of it?
Yeah, so can I do that at the end? Yes, definitely. So you'll have u minus 9, u minus 4. Does that make sense, guys? Yes, no, okay. So you're going to have u equals 9 or u equals 4, right? And then your u was equal to x squared, right? So that's x squared equals 9 or x squared equals 4. And so what are if x squared is 9, there are two answers for x there. What are they?
3 and 2.
Plus and minus 3. Don't forget your plus minuses. And the other one is x equals,
Plus or minus.
yep.
So you actually get 4 answers.
Yeah, and I don't know if you guys learned this in algebra too, but I taught my students this, that the number of answers you get with a couple technicalities is almost always equal to the highest power. Does that make sense? And there's something called multiplicity where you get answers more than once, in which case it always matches. So that can be a hint. Okay, now Willow had another method that is also legitimate and a bit faster. So she said, couldn't you do this just by keeping track of the exponents? And she's right. I think what she meant by that is you could think, well, x to the fourth, it had to come from x squared and x squared. Is that what you were thinking, Willow?
Yeah.
And then she's like, okay, well, now we have to multiply to 36, so minus 9 and minus 4. Does that make sense? It's the same thing? And so then she would get x squared minus 9 equals 0, x squared minus 4 equals 0. And so she'd still get x squared equals 9, and she'd get the same answers, right? If you want to do it that way, that's totally fine, okay? Like, that's not a problem. There are some slightly more complicated ones where knowing the substitution idea is important, but honestly, once you get good, it's totally okay to just keep them with x's and use that pattern. Does it also make sense to everybody else that this, oh, it doesn't work to erase it when I have to, oh, bummer. Okay, well, whatever. Let me write the original problem over, that'll be fastest. So the fact that this worked was very dependent upon the pattern in the exponents. Would this have worked if that would have been a 13x? Does that make sense? Like, if this had been x and not x squared, would the whole factoring thing have worked? It wouldn't have, right? And that's one thing that I think the substitution makes a little bit more clear, because this depended upon you being able to replace that thing by a u and not some u to a funky power. So these problems are sort of doctored to work out special, and the pattern is that this number, this power, has to be half of that one. It's like if this were a sixth and that were a third, it would also work. So we'll do some more complicated ones, but that's kind of the most basic one. Okay, holy moly, this one. Does this one factor? I don't think it does. So let's do the substitution just to practice. You'll let u equal x squared, right? So u squared is x to the fourth. That becomes 2u squared plus 3u minus 4 equals 0. Does this one factor? I don't think so. You try to do that like trick where you multiply the 2 and -4 and you get -8, right? any factors of -8 add to 3? Here, no, okay. So now solve using the quadratic formula. You're gonna have u equals negative b, so -3, plus or minus the square root of b squared, which is, gesundheit,
9.
9, great, minus
32.
4 times 2 times -4. I'm just not as fast as you are. All over 4. I think I have short-term memory loss. -3 plus or minus the square root of, you said 32? Do you guys
No.
agree with him?
9 plus.
Oh, you said 9 plus 32. I see. The 4 times 2 times the 4 was 32. Yes, So square root of 41 in that case, yes? Okay, over 4. So is that your final answer?
I think so.
But it's u equals, not, and the original thing had x's in it.
So you have to square it.
So it's really x squared equals that stuff. And is he right when he says you have to square it?
Square root.
To square root it, yeah. So x will equal plus or minus the square root of all that stuff. I don't think you have to simplify that any more than it already is.
Well,
You could say over 2, right? That would be okay, that would be easy to do. So Willow, if you didn't want to make the substitution, you would just have to start here by saying that that's x squared equals, and it would be the same thing. You guys understand what I meant by that? Okay. So hopefully Alex doesn't want you to, and does that make sense that that's also actually 4 answers?
Yeah, because you have 2 plus or minus.
Yeah, so you've got the positive one where this is also positive, positive one where that's negative, the negative one where that's positive, and the negative one where that's negative. Some of them are going to be imaginary answers. You're going to have a negative inside that radical sign. That's really ugly and won't come up very often, but it's just good to be aware of the whole substitution pattern kind of thing. Okay, so here's a couple trickier ones. So would substitution work for these, and what is the substitution? So we didn't do any harder ones. Let me write down one that's a little bit simpler. I'll write down, we'll call it letter Z. Let's say x to the 6th plus 2x cubed plus 1. What would you substitute for that one? U equals x cubed. And how you can tell then is u squared is x cubed squared. What happens to those powers? They multiply, they get x to the 6th. So the pattern is that the middle exponent, when you arrange them, well, kind of from biggest to smallest, but that's not quite true of these next ones. This is half of that, right? Is the same pattern true for this A one?
Yes.
Yeah, so what you could do for this one is you could let u equal x to the -2. Does that make sense? And then u squared will be x to the -2, the whole thing squared, and what does that make? X to the -4. So that's your substitution. The answer is yes. This becomes 3u squared plus 2u plus 7 equals 0. Using that u. Which if you can keep proper track of it, you could say, you know, it's going to be something with x to the -2 and x to the -2. It's also totally fine. Could you make a substitution and do part B?
No.
No. How about part C?
I think so.
Yeah, here's how you can really tell. Does it make sense that root x is x to the 1/2? So if you have x squared times x to the 1/2, what happens in the powers?
Yeah.
They add, so 2 plus 1/2 is 2.5, right? So 4x to the 2.5 minus 6 equals 0. So is the halving pattern there present? So the substitution you'd make would be u equals x to the 2.5. And that'd be 2u squared plus 4u minus 6 equals 0. So you can choose if you do or do not want to actually use the letter u and substitute. Yeah.
Could you also think of the first term being two x squared root x?
Yes, yeah, you could think about the first term as 2x squared root x squared. You could think about it like that.
Yes.
Yes. So you could think that that first term is 2 times the quantity x root x squared. Is that what you're thinking? Yep, exactly. You totally could. Okay. Yeah.
For B, why couldn't you sub it in?
Because this subbing pattern depends upon this thing being the square of that thing. So what will, in order for the pattern to work, you have to be able to, and I think I wrote that a little wrong, Willow. This should have been squared right there. So, yep. If you take this thing and you square it, you should get that. Otherwise, the pattern won't work. Okay. All right, so here we go. Your book had this one first, and I thought fractional exponents are a bit tricky, so. Yeah. So let's actually make the substitution. If you don't like it, you can also do it the other way. So what would you possibly substitute here? X to the 1/3, yep. And then u squared is x to the 1/3 squared, and what happens to those powers? They multiply, right? What's 2 times 1/3? 2/3. So that thing's replaced by u squared. This thing is replaced by u, and the 6 just stays. And the idea of substitution comes up in calculus, but it's in a different context. It's not like with these equations. So does that factor? Yeah, u minus 3, u plus 2, right? So if I say u equals 3 and u equals -2, does that make sense? Okay. So x to the 1/3 equals 3, and x to the 1/3 equals -2. And how do you undo a power of 1/3?
Cube.
You cube it, right? Because it really is a cube root, so the opposite is cubing. So this will give you x equals 3 cubed, or 27, right? X equals -2 cubed, which is almost -8. So if you had skipped the substitution and gone straight to the factoring step, you would have factored into x to the 1/3 minus 3, x to the 1/3 plus 2. Does that make sense? Okay, so if you think you like that, you can also do it that way. We could do the next one that way, for example, just for kicks. Okay. So is the whole halving pattern present here so we can do this? Yep, okay, so in that case, if you did a u, you would let u equal x to the 1/4, right? Okay, so if you do it the other way, if you just factor off from the get-go, what's going to go in the first spot? X raised to the 1/4. And you can think, okay, x to the 1/4 times x to the 1/4 is x to the 2/4, which is 1/2, right? And then what numbers go elsewhere? -2 and -3. That way is faster, isn't it? So if you can handle it that way, like, it'll save you some time. And so you'll have x to the 1/4 minus 2 equals 0. X to the 1/4 minus 3 equals 0. So x to the 1/4 equals 2. And how do you undo that fourth root? raised to the power of 4, very good. So x will equal 2 to the power of 4, which is 16. Great. And this one will be x to the 1/4 equals 3. X equals 3 to the 4th, which is 81. Great job. Should I show you what the substitution would be as well? Do you want to see? Okay. If you did this substitution, does it make sense that u squared is x to the 2/4 or x to the 1/2? So if you substitute, you're going to end up with u squared minus 5u plus 6 equals 0. And my guess is you could get it from there, right? Does that make sense? Yeah, okay. So either method's fine. I don't know what you guys prefer, and my guess is like half of you prefer one, half of you prefer the other. So, no, this second way, the one that Willow suggested, is definitely faster once you get the patterns down. So I would suggest beginning with the substitution thing if you're a little bit confused, but always trying to ask yourself, like, okay, how could I have skipped that and gone like straight to the factoring step? Okay, and then just some random stuff. So, random stuff, how would you start this one? Square both sides. So you're going to get x squared equals 5x squared plus 9. So, okay, well, what do you think? So sure, subtract x squared. 0 equals 4x squared plus 9. What else could we do? Minus the 9? What do you think? Okay, negative 9, or the 4x squared, either one. So negative 9 equals 4x squared. Now, do you want to divide by 4, or do you want to take a square root? Square root. Okay, so square root both sides. When you do that, what are you going to have to introduce? I. So we'll say plus or minus 3i equals 2x. Does that make sense? So x equals technically plus or minus 3i over 2. Now there is one technicality here. The only answer that you have is the positive one. Now I don't want you to actually have to check, but the reason is that if you check, so if you check x equals negative 3i over 2, when it goes into this side, it's a negative number, right? And only positive things come out of the thing on the right. So that's why the only answer is 3i over 2. My guess is if you get that close, Alex tells you something like, you have extra answers or you're almost there or something like that. Okay, let's do one more. Yeah, put your stuff away already. Here, this you're already done. Okay, so this one, it looks really, really, really nasty and complicated, doesn't it? But if you think, so do you think it would be easier to make a substitution or to expand everything out? Make a substitution, right? And what do you think you're going to substitute for? M squared plus 2m. Yep. So that becomes u squared minus 6u equals 16. Or u squared minus 6u minus 16 equals 0. Does that factor? What, u minus 8 and u plus 2, does that make sense? Okay. So what two things would u equal? Negative 2 and 8. So one thing is m squared plus 2m equals 8. And the other one is m squared plus 2m equals negative 2. And we hope they both be solved by factoring. So first one is m squared plus 2m minus 8 equals 0. Does that factor? Does that, yeah. M, what multiplies to make negative 8 and adds to 2?
4 and negative 2.
Mm-hmm. So one answer is m equals negative 4, and the other one is 2. Okay, we got two answers. Woo! Don't write this down because it's not going to work. When you try to factor this one, does anything multiply to 2 and add to 2? No. So your options are quadratic formula or complete the square. Is this one of the ones where completing the square will work out pretty nicely?
Yes.
Yeah. So what number do I add to both sides?
2.
I think 1. So I add 1 here, and I do negative 2 plus 1 there because I'm going to complete square. That's a bad square. Now it's a square. So that's m plus 1 squared equals negative 1. I promise I'm only going to go 30 seconds over. So m plus 1 equals plus or minus I, great. And m will equal negative 1 plus or minus I. Okay, awesome.